welcome to the webinar. Welcome to the webinar. I'm Mike Bowers. I'm the Chief Architect at FairCom, and we're presenting on today on JSON meets SQL meets event streaming. And I'll be presenting and doing a live demo. Got a few introductory slides, and and just so you know, for some reason last night I came down with laryngitis, and so my voice is a little scratchy today. So hopefully it will be alive and well during the whole presentation and not drive you crazy. We have a quick poll we'd like to do to ask you how familiar you are with event streaming. So we're going to pop that up right now and answer the questions, and then I'm going to describe event streaming very quickly for you. Event streaming is the next generation of message queuing. So we've had message queues forever in the industry. I remember back in the day, we had the IBM MQ, which is still around, and you got NVIDIA and Microsoft got in the game with their MQ, and then we've got AMQP protocol, which is really a Java API for Java applications, so they can publish and subscribe to messages. And we have products like ActiveMQ and RabbitMQ, the Cupid, and those kind of open source projects. Then we got Kafka, and Kafka did a new twist on it. Kafka stored an event log, and that's basically the big difference between messaging and Kafka, is that Kafka is more of an event log system where you can stream events into a log and you can replay them in order so that you can do all kinds of cool use cases we'll talk about in a minute. The cool thing about combining messaging with event streaming is that there are strengths to each one. MQ uses a push technology that can actually push an event to a client and interrupt them. And when you interrupt them, it just says, here's a message, and then they can get the message on demand, which is really cool. And that feature is built into the protocol that FairCom uses for messaging, which is MQTT. MQTT was invented by IBM many, many years ago, and it's become an internet standard that is very popular today because it's so simple, and you can push messages and publish them so easily. And then you publish messages to a topic, and people can subscribe to the topic, and machines can subscribe to the topic, and they all get the message. What FairCom has done is we've taken that MQTT protocol and we've merged it with an event log in our database product. And because our FairCom is a database company, and we've been in business for over 45 years, and we're really fast, excellent database technology. So we merged MQTT with our database technology, and they're completely united. They're one thing. So every single message coming in is always in an event stream log. And so you can now query the event stream with database technology, which is even better than Kafka, because now you can use SQL to query it and filter it. You can use our JSON DB API to do that. And of course, you have MQTT with real push messaging. So you have a true internet standard with MQTT. You have true easy APIs like JSON, and you have standards like SQL, all doing the same thing on event streaming. So it's exciting. I'm going to show you today how we've merged all those things together. So all the capabilities you would expect from Kafka, you will find in a database, FairCom DB, and all the things you would expect from an MQTT broker, you'll find in our database, FairCom DB. And everything you'd expect in a database with SQL, with JSON, like MongoDB and Couchbase have JSON, you have in FairCom DB, but they're all converged into one database platform. So I want to talk a little bit about FairCom DB's value proposition, because we have a really unique product that combines that event streaming JSON and SQL all in the same data at the same time. One of the really cool features is a low return on investment. Now everybody says those kind of things, but I'm dead serious. This is an amazing low cost database. My last job, I was the data architect for a large multi-billion dollar organization, international. I was the number one data architect for the whole organization. And I was in charge of all the database technologies, all the recommendations, all the standards for database, transactional databases, analytical databases, business intelligence, um, master data management, everything to do with data was under my domain at that company. And FairCom recruited me to leave that company and come join FairCom about 6 years ago. Because in that process, I had been wanting to get a new kind of database created because I was part of the NoSQL revolution. I love JSON, I love SQL, and I love merging those two together. And no one until I did this at FairCom, no one had merged JSON and SQL in the right way together. It just didn't. It just never hit the easy mark, and it wasn't powerful enough. And so I designed a whole new solution before I was hired at Faircom, and we've been implementing it this last 6 years, and we've released it. And I'm so excited to share it with you guys. But Faircom has a long history of no database administrator required. And so that's part of the core Faircom technology. We have customers who run the Faircom database for over a decade and never had a DBA, never had a downtime. You don't have to tune anything. It just works because we have several engines in the Faircom database. We have this core engine that has been proven over 45 years is so simple, so fast. Um, it just doesn't need a DBA to do anything to make it better or tune it. And so applications literally run for years without downtime or any problems. And you don't need to tune the thing with the DBA. Now, think about the cost savings. If you don't have a DBA is going to cost you total cost of ownership of a DBA is somewhere between 200 and 300,000 a year, depending on the DBA, but and all the benefits and everything. That's a lot of money. And normally you need two, right? You need to have they got to back each other up. And I was in my last job, before I became the data architect, I ran the Oracle SQL Server and MarkLogic database core team. That's where all the other database teams of the organization. And I know what it means to run Oracle. I was an Oracle DBA in my career and a SQL Server DBA. It takes a ton of effort to manage the Oracle database. Postgres is even more complicated to manage and hard. SQL Server is easier, but still requires DBAs. And MarkLogic was like SQL Server. And we had MongoDB, we had Cassandra, we had our DBAs to manage the whole cluster thing because it got fragile and started breaking all the time. So, and MongoDB didn't scale, so you're constantly tuning that with your DBAs. And Postgres is just always you're tuning that thing. So if you can get a database without a DBA, you're going to save yourself anywhere from, if you're really cheap and only have one DBA, $200,000 a year, to if you have two, like most organizations, you're going to save yourself, 200 to or 400 to 500,000 a year. That's way more than your license costs. That's extremely expensive. So think of that alone ticks the box for lower ROI. And this is very real. When I was first hired by Faircom, I went to London. We met with Visa in London. Visa uses the Faircom database in Europe to run all the Visa transactions. So you swipe a Visa card in Europe. Until recently, when the U.S. took over the whole operation, they bought Visa Europe and took it over. And now they run everything in San Francisco on a different set of technologies. But until recently, every Visa transaction in Europe was swiped in real time, tracked in real time in the Faircom database. That thing ran for over a decade without any problems. They had DBAs for Oracle and SQL Server and Postgres and MySQL at Visa Europe because they needed them. Those Oracle DBAs actually, I was at lunch with them. They were kind of complaining to me, we never do anything with the Faircom database because it always works. You don't have to tune it. You don't have to do anything. And we're kind of scared because it never has any problems. But one time we had storage problem and we called FairCom support. And of course, FairCom support was fantastic. And it really is, to be honest, it is, we have the best support I've ever seen in a database product. And I've worked with all of them. Like you've seen the things I've said earlier. And that we got them back up and running real quick. And it wasn't the database, it was storage. They ran out of some storage. So the cool thing is it's very real. We have no DBA needs, low developer costs. Now, until recently, FairCom DB had a C, well, still does, has a C API, which you can get performance that is literally unbelievably fast. We have customers using that API are getting 500,000 transactions per second all the time, every day, all year. And the database doesn't go down. It's rock solid. When I did Oracle Exadata at my last job, we spent millions of dollars buying Oracle Exadata just to get 30,000 transactions per second with a ton of tuning. And I wasn't happy with that. So then I designed a whole new replacement for Exadata. And because I knew how Exadata worked, and I designed a replacement that used Oracle on different hardware that was tuned and optimized. And we were able to increase that a little bit, but save a lot of cost of not having to buy Exadata. So I'm experienced with huge projects, multi-million-dollar projects, big database solutions, designing replacements for those things and making them work. FairCom DB is on a $60,000 server. In our lab, we're getting 1 million transactions per second. Over the weekend on my laptop, I was just running a test, and I just got 30,000 inserts per second on my little, my just a normal laptop, and I wasn't doing anything. And in fact, one of my developers, he says, "Well, Mike, you did this wrong," and he got 80,000 on his. So this is just super fast out of the box. So no DBA, high performance, low developer cost. Now, writing code in C is expensive. So FairCom DB's recently released a couple years ago our JSON DB API, and we have JSON APIs to do event streaming and messaging, and in fact, we have JSON APIs for managing the entire database. I'm going to demo all that today. So low developer costs because you can program in any language, and all you have to do is post JSON to an endpoint. And I'm going to show you it is so easy. It is so fun. You don't need a driver. It works in every language because every language can post JSON and works with JSON, and every language can post JSON to an endpoint over HTTPS. So it's super easy. So your developers can build solutions so quickly and efficiently with this, and I'll show that in a few minutes when we get to the demo. Low license costs. Our product is very inexpensive. We compare very favorably to every other database on the market. Trivial installation. I mean, it takes days to install an Oracle database. Other databases are easier, but our database, unzip and run it. I do it all the time. I just download a new version of our product coming out of engineering and zip it, and I just run it, and it's up and running. We have Microsoft installers and all that stuff too. And we can run as a service. We made it so easy for you to install, and you can run anywhere. You can run on premise, you can run in a Docker container or Podman, you can run in Kubernetes, you can run in the cloud, you can run in private cloud. We've got customers like Verizon who are running in their private cloud. We got Verizon who is using everything I'm showing you today. So everything I'm showing you, if Verizon uses it, and when you make a phone call on Verizon, there you chose our database because of the low latency, high performance, predictable every time, high speed performance. And they're using our JSON DB API. They're using our messaging, our MQTT. They're using all of this. And I'll share some use cases. And they're building their next generation phone system on our product because of these powerful features. So you need fewer servers because the thing runs so fast. You just don't need to install so many servers. Well, that saves you license costs. So this is legit. This is not me just promoting something. The low ROI is amazing and true, and you're going to save a ton of money. And it's cheaper than open source, which you think is free, but then you have to buy their enterprise version, and they charge you all the cloud fees and everything else for it. You really have to try our product. And if you want our source code, well, we'll ship you our source code when you buy our product. So we give you source code. So that's our low ROI. We're super high performant. I mentioned we run anywhere. And the cool thing is we're an event streaming database, um, and a JSON database and a SQL database, all in the same time on the same data. So you could do event streaming on the same data as you do JSON queries in JSON and do the same thing with SQL, all in the same data at the same time. The productivity you get from that is amazing. And what's important is that event streaming isn't a solution for every use case and every need. JSON is high performance, very tuned, and I'll show that in a few minutes. Very tuned, simple queries to be able to do things very quickly and easily and fast. SQL is your all-purpose. It's there. It can do anything. And if you're building an application, if you don't have a SQL database in your application, just expect to have major problems because you're going to have to put one in there eventually because your scope is going to increase from like a simple key value or even a MongoDB or Couchbase JSON store that can't do joins because everybody's going to ask for some feature at some point where you're going to have to join your data or you're going to have to query on a column that is not indexed and you have to sort it a different way. SQL is so powerful and flexible. So you need that in your application, but you also need the specialty features of a JSON to do those high performance, predictable, low latency queries that bypass that layered SQL engine that has all those layers that slow things down. So all the capabilities you get from SQL are awesome, but they slow you down in the performance. So we give you both. We give you the high performance JSON, the easy, and we give you the SQL so that you can do anything you ever need to do to meet your application development needs. And we give you event streaming. So why is event streaming so cool? Well, every modern application starts to want to do the following things. Think of Slack. Slack. If I were building a Slack today, I would not hesitate for a second. I would choose the FairCom database instantly for that because every feature that Slack has with the real-time messages, every time you Slack someone, you're really publishing a message to a topic. And then everyone who is subscribed to that topic can see it in real time. Well, it's built into the FairCom database to do all that. So, and then you want to go back and see the history of all the messages. Well, that's built into the FairCom database because it's the event streaming log. You want to go search, built into the FairCom database. You can search for previous messages, find them. All the features of Slack are built in. So you could just unzip and run FairCom DB and build a Slack in weeks and have a fully powerful, wonderful Slack replacement. But just imagine what you could do to your application if you could put that in your whatever application you're building. The ability to do chat, to be able to Slack people, to be able to communicate real time. So the next bullet point, let's say you wanted to build something like Google Docs or build Google Spreadsheet or this, any Google of those interactive collaborative solutions. They're using a database called Firebase and Firestore that to make all that happen. Well, you can use FairCom DB for that. Why? Because we run anywhere. You can run it on premise. You can run it on the edge in a factory. You could run it in your office. You can run it in your data center, your private cloud, wherever. You don't have to run it in the cloud and pay all those expensive fees for database as a service. But you can run FairCom DB in the cloud too. It's so easy. You just unzip and run it into an EC2 instance at Amazon, and it doesn't need a DBA. So think about cost savings. You don't have to pay for all that expensive database as a service in the cloud. If you're a startup, it's so easy just to go and throw FairCom DB in the cloud, have all these features, and you're done. And it's easy, it's simple to pay a fee to somebody to host a database for you and use database as a service. It's going to cost you for the data, cost you for every transaction. This makes it so much cheaper. And you can build your app on your laptop, and then you can do the exact same thing in the cloud. And we also have data replication in our product, so you can replicate between your local system running locally and your cloud back and forth. We have some amazing features that make all this easy. So real-time collaboration, build a Google Doc system. FairCom DB will scale and handle it beautifully. Behavior tracking, you can track point and clicks by your users and find out what they're doing, and you can replay those things. Those are all event tracking systems, so we can do all that in FairCom DB and get the event stream of user clicks. data synchronization is so cool because FairCom's event streaming engine guarantees delivery in order, and guarantees delivery only once. So when you talk about that, you got in order delivery only once, guaranteed. It's in the event stream that way, but it's also pushed out to you through MQTT in real time in order. So you can count on FairCom's event streaming to do data synchronization. And we built that into our product. So we also have built-in data synchronization that will send data change events over JSON as JSON messages, and you can subscribe to them. So you can even just subscribe to data change events in our database and get them over MQTT, or look at the event stream and see them, replay them. So you can have them pushed out to you by subscribing, or go replay them out of the event stream and get all the data changes and replay them in any other database you want. Replay them in your caches. This is what Verizon is doing. They have microservices, and they're tracking real time things in the FairCom database, and then they're synchronizing those out to a big farm of microservices. And FairCom, our data synchronization technology, is keeping all those microservices up to date. All their caches are up to date constantly. Um, Push notifications, commands. If you're in a factory, you can distribute your command. You can send commands to devices, and we have customers doing that right now. We also could do distributed command processing, which is where you subscribe to a shared topic, and we can deliver a message to a topic to different clients. Normally, what happens in MQTT or in event streaming, everybody gets every event. So if you subscribe to a topic, everything published to the topic goes to everyone. But when you create a shared topic, then the server behaves differently. It distributes the messages one at a time to everyone who's subscribed. So now you could create a distributed command processing system, have a farm of servers, and they're just listening to the subscriptions, and FairCom will distribute the messages to you, to each of those clients. So if 100 messages come in, you have 100 people, 100 computers in your farm. FairCom DB will distribute one message to every one of those 100, and the next 100 will distribute those again. So now you can do distributed processing. If one of the clients goes down, no problem. It just FairCom DB will just send the message to another one. So it's so easy to build a distributed command processing system. Think of machine learning, and you need to process it on many servers, or image processing. Super easy to do. I'm not kidding. It is so easy. I can't wait to show you this and all. So I got to go faster, get through all this use case stuff. Issue monitoring, performance monitoring, distributed user profile caching. That's kind of like Verizon is distributing everything to your caches. This event streaming is so powerful. And let me show you now. Let me get out of this PowerPoint thing and go into the real demo. So right now I'm going to, if I haven't timed out in my UI, this product I'm showing you right now, these user interfaces are built in to the FairCom product. So I'm going to publish a message to a topic I created called webinar. To create a topic, all you have to do is publish to it. You don't have to do anything fancy to create one. So I just earlier today did that, and there it came through. I'm going to show you MQTT is the industry standard, and it is the only industry standard wire protocol for messaging. And that's an important point, because now everybody can plug and play with MQTT, and everyone does. Kafka does. ActiveMQ, RabbitMQ, Cupid, all IBM MQ, all the message brokers play with MQTT because it's an industry standard and it's easy to use. And so I'm going to now take a MQTT client that I have, and where did it go? Here it is. It's really small, and it's not my fault. I don't own this software, but here's the message I just published. How can FairCom DB combine JSON, SQL, and event streaming on the same data at the same time? Well, I'm going to show you in this demo. So I just published that message. I could publish anything here. I could say, "Hi everyone. I'm just publishing to this topic." And as soon as I do, this subscriber over here got it, and over here, this MQTT client gets it. If we had Kafka subscribing to this, Kafka would get it. So would RabbitMQ. So with IBM MQ, they would all get it because everybody's compatible with this industry standard. And I'm going to say it again, MQT is the only industry standard that for messaging that is an open standard that is interoperable across everything. And FairCom DB has built that into our product. And just so you know, this is not an open source thing that we grabbed some open source client, threw it in our product and said, oh, cool, we can do this. We built this. We built this MQTT feature in our event streaming feature into our product. We wrote all of the code. It is in there combined with our database technology at the fastest performing level. We fully integrated it. It's not a side thing. It is owned by us, and it is so effective and efficient and reliable because we own everything of it. There's no finger pointing. You come for support to us, we own everything we build. You're going to get full support because our engineers made it. We know how to fix it if there's any problems you find. Okay, let's go back to the demo. Okay, so I've published some messages. Let's go look at our event streaming queue. So here it is. Here's our message webinar. And here is some event streams that I have. So all right. So here is just the messages I published as I was waiting for the webinar to start. So you can send anything in the payload. It could be JSON, XML, it could be an image, it could be a video, it could be a PDF, anything, literally anything can go into the payload and we can store it and we can forward it to all the subscribers. It's just built in. And so notice the viewer here, I didn't do any images on this, but notice I have a combination of some JSON. I've got just some text. I should have played with an image, but anyway, it does support all of that right out of the box. And notice this event stream, this user interface is built on our event streaming technology. It can walk through all the messages in the history. And just if you're worried, like what if you're sending millions of messages a day, which is no problem, easily, trivially in our product, even billions, you can walk through all those records, but might get pretty big on disk. So we have retention policies. Every topic has a retention policy. It has a default one. You define the default. And then you can change that. You can change it. You can retain messages day by day, for a certain number of days, like 15 days, or week by week, or hour by hour. And we will automatically and efficiently remove the old messages. They're just gone with no performance cost to you at all. It just the data is immediately wiped out as soon as as soon as you've got new data and the old data is out of date. It's gone. So we have a really simple system that you can configure with your retention policies. So I've shown you so far some event streaming that's getting the list of data. I've shown you publishing a message. And now I did time out on this one. I was too long. So let me go and create a new connection. Okay, so I'm going to connect to my server and I'm just going to change because I'm going to demo our database features. So I'm just going to make that the default. All right, so this is our data explorer. And I'm going to now show you the same data that I just showed a minute ago, the webinar data. So here they are. Here's the data. I can open up a source payload here and show you. See, there's a message. I'm going to run a SQL query. Select all from the MQTT message webinar and run that. And here they are, the same data coming across through SQL. I'm now going to go show you my favorite part of all is the JSON APIs. So this is my baby, and our engineering team is so awesome at FairCom. They build amazing things. So I design it, and they go off and build it, and it just makes me so happy to go play with the things that they've implemented because they're so good at it. So I'm going to go and do an example real quick of publishing a message. So I'm going to replace this one here, and I'm going to show you how to publish a message. So I've created a client in MQTT and in our event streaming system. Everyone who is connected has a client name. And so my name is Mike, so I created a client name called Mike, and you can put anything you want here, and really long strings too. You have really a lot of flexibility here. So I'm going to publish a message using my client Mike identifier, and I'm going to publish to the topic webinar, and I'm going to publish a database with the event streaming. That sounds crazy. So I'm going to run this, and I didn't get a message. So it supposedly worked. Let's go see if that third-party tool got the message. Database with event streaming. There it is. So here's a third-party tool that got it. I published. Think about this. I published using JSON API. All I had to do was send this JSON message, which is super simple, to an endpoint. I just post this JSON to an endpoint. Every language in the world can post JSON to an endpoint. You don't need a driver. This is driverless technology. You just post this JSON to the endpoint and you can publish messages. You can publish messages using HTTP and post. It is so fun and so easy. And of course, we translate it automatically to real MQTT. So this is a real MQTT broker using the MQTT protocol, which requires TCP/IP, sends a bunch of packets back and forth, does a real guaranteed message delivery using a protocol. So we've converted it HTTP into real MQTT automatically under the hood. So if you're an MQTT client, you get it. If you're an API client, you get it. If you're in the database and you want to see the message, let's see, is it in the, let's close that one out. Let's see, go over here. Let's refresh our event queue. There we go. There it is, database with event streaming. So now I'm reading the records. And I can show the records over here as well. Go back to my data explorer where I lost where I was. All right, so let's come back in here and show you the records right into this MQTT table. Here it is, webinar. So here's all the records, and here is the database with event streaming. So you can see I can get the same data no matter how the same data is available, no matter how it comes in or how it goes out. That is the power. And that's where FairCom DB really shines. So here's the same data using SQL. So this is where developer productivity really comes in. But I want to show you a couple more JSON messages real fast, just so how easy it is to get messages. I got messages using SQL right here. But what if I come over here and I'm going to run this get messages from our topic, and I'm going to use the webinar topic. I'm going to just grab the last message we sent. So here it is. Let's go look and see what came back. Here is the message. Here's the payload, a database with event streaming. So you can very quickly use a JSON API. You can use SQL. You can use our MQ API. There's a whole bunch of APIs you can do that fit your needs to get to do pub sub, to do database queries and everything. Now I'm going to switch gears for a minute, and I'm going to show you this API Explorer and how you can use it to create tables, manage all your database tables, and query data. So I'm going to go create a table, and these examples are built in. When you download our product, go to the Data Explorer, and so you just go to our web endpoint for our web apps, which is your local host, and it's port 8443. And then in there, you'll come up with a menu. In fact, if I just do that right now, you'll see what I'm talking about. So I'll just go to 8443. It'll come up with a menu, go into Data Explorer, and I'm going to change to the database. So I'll connect it another time. So you can connect multiple times. I'm going to go and view, and I'm going to go create now. So built-in tutorials that are just right here. So when you come in, go to the API Explorer, inside of Data Explorer, and you can go create tables and do all this cool stuff. So I'm going to create an athlete table. So the athlete table is really fun. It has a name, a rank, a birth date. Where these are some famous athletes we're going to put in here, like Muhammad Ali, Michael Jordan, Pele, etc. And so, how much money did they make in their lifetime? What's their favorite saying? That kind of stuff. In fact, I'm going to add one more on the fly. So let me go and add after their name. I'm going to put a new one. I'm going to put a metadata field in here, and I'm going to make it JSON. And I'm going to make it pretty big. I want to let it hold 65,000 characters. So, and notice I just on the fly added a field. Notice it's easy. Copy paste coding is so easy with this JSON thing. We've got examples. You can just like filling in the blanks. Building an application that generates this is so easy because your applications generate JSON. We have APIs in the app to do this in their sleep. And so it's like filling out a form. This is easier than MongoDB's query language, which puts all kinds of weird stuff inside property names. You got to do all kinds of weird stuff to get their query language work. Ours is just simple and easy because you could code it without parsing anything. You just use your JSON, built-in JSON features in your app and your language, and you can just build these things. So I'm going to run this now, and let's see what happened. So I'm creating a table. I didn't get it. Every time you post this, all this API Explorer does is take a JSON and post it to our endpoint, and our endpoint is /API. And then when it comes back with a result, it gives you, you just look for error codes. If there's no error code, you know you're successful. We've got lots of debugging and troubleshooting built in. So we're really helpful and to you. So we make it so easy to figure out if something goes wrong, why it went wrong or anything, if your code is not quite right. But it's hard to do it wrong, really, because it's so easy. So I created a table. And now I just ran a SQL query by clicking on this. This uses the SQL backend, and the athlete table showed up. I used JSON to create a table, and SQL can now query the table. So let's go. I'm showing right now there's no records in it because I just created it. I can query it. I guess before I do anything, though, I want to always create some indexes. So let me do that before I get carried away. So let's go and create an athlete ranking index. So to create an index, I'm just going to go, here's the table name athlete. Here's the index name. I'm going to make the index on the ranking field. So let me go run that thing. And there's no error. Let me go create another one, an earnings. So let's go create the earnings index on the earnings field. So now I can use some specialty queries and query by earnings or ranking or by athlete name, which I'm going to do next. No error on that one. Let's go down to the last one. Now I've got an index on the name field. I'm using some special features just to illustrate we could do more than just create an index. We can create indexes on multiple fields. In this case, I'm creating an index on the name field, but I'm saying the index is case insensitive. The index will actually be sorted physically in descending order. We have a fancy feature called reverse compare that's really cool for specific use cases. I won't get into the details now because of time. This cool conditional expression is really neat. This is one of my favorite features. I love this feature in the FairCom engine because FairCom can create 2,500 indexes on a table. That's a lot. DynamoDB, you might get 4 or 5, and then you have to ask permission to create more. And every time you create an index in DynamoDB, you're paying for the entire database to be copied over to another one, because their index is nothing more than a complete copy of your data. And it doubles your costs, and it doubles your query costs. Every time you run a query, it doubles your costs. There's no extra cost to create an index here, and you can have lots of them. And here's the cool part. You can create conditional indexes. Basically, a conditional index is a predefined answer to a question. In this case, I've done a real trivial thing, but I've said, give me all the athletes, only index athletes that lived past 2000. Now you can get really complicated expressions in here. And when the record is inserted or updated, the index includes the record only when it passes the conditional expression. So it's super easy to create a query that is already answered by an index. And all you have to do is use one of our JSON queries and say, use this index and walk the records. And you'll get the answers back, and there's nothing faster. You can get tens of thousands or hundreds of thousands of records back a second, just boom, and thrown at you faster than your app wants to consume them, that are pre-indexed, that are already filtered because you pre-filtered them. And you say, the savvy guys among you are going to be going, yeah, but the more indexes you create on a table, slow down inserts, updates, and deletes. So who in their right mind would ever want more than a handful of indexes on a table? And you'd be right, except for FairCom has another really cool feature that's unique. We could do deferred indexing. So your critical indexes that you must have always be up to date. You make them like normal, and they're always up to date. When you commit a record, that index is up to date. And so the index is 100% accurate with the data at the table. These extra queries, you can decide if you want to make them um, deferred or not. And if you make them a deferred index, then what happens is the record commits without the index being updated, but it's immediately put into a queue that updates the index very quickly within fractions of a second. Or if you have huge massive loads like 500,000 transactions per second, you might be a couple seconds. But your indexes get updated asynchronously, so you can afford to have hundreds or even thousands of indexes on a table with these pre-answers to questions. This gives you a level of performance that no one could touch. And SQL can't even get close to this. So I love this feature, as you can tell. So I've created my indexes. I think I ran this. Let me see. It'll give me an error if I didn't run it yet. So I ran it now. If I ran it again, it's going to give me an error because it exists already. So there's the error. All right, so I've created the indexes. Then you go into, well, let's go run some queries real quick. Let's see what we got. We haven't inserted any data yet. So let's go select all the records from our athlete table. Okay, select star from athlete. Nothing's there, right? I can go look at this table record here, refresh it. Nothing's here. But we've created the table. It's showing up over here. And you can even drill down and say, oh, what kind of indexes do we have on the thing? Now it's going to show us the index we've created. So we've already got a nice exploratory package built into our product so you can manage it easily if you like to point click. All right. Let's get some records in here. So I'm going to insert some records. This is all built in. So just download our product, go to the Data Explorer, import 8443, and go into our Data Explorer app, go to API Explorer, run the tutorials. So I'm going to now insert these records. Now notice every record is JSON because this is a JSON API, and these are JSON commands. And what I want to point out, this is the simplest JSON you'll ever see in an API. And I worked really hard for this. All you have to, everything's encapsulated. All you do is post this JSON to an endpoint, to our API endpoint. You don't have to put anything. There's no URLs. There's no cookies. There are no query strings. You don't have to do anything that's special like you have to do in REST. This eliminates all the complexity in REST. Everything is in this JSON. Everything you need, and it's easy to read. You can just read it like a book. Okay, I'm inserting some records. What's the table? Athlete. I'm going to format them as objects. Here's an array of the objects. The source data goes right here. Okay, so I'm going to insert an athlete record. And then here's Michael Jordan. What's his birth date? He was born in 1963. Same year I was born. He's player number 23. He did live past 2000, and he has earned $1.7 billion in his lifetime. And I think that's a couple years old. So I know probably over 2 billion today easily. I love his saying, there's no I in team, but there is in. We got Babe Ruth in here. We got Muhammad Ali in here. Pele, Wayne Gretzky, Michael Schumacher. I went on the internet, and of course, the internet always tells you the truth. And this was the top ranked international athletes in the world at some point. So who knows how true that is. But anyway, I built this data out. We're going to insert it. Let's see, did we get an error? No errors. So it worked. So now let's go back and rerun our SQL query. Boom. And look at that. I use JSON, the easiest thing in the world in an application, way easier than SQL. And I inserted these records from JSON, and they're in the SQL engine. I could query them. Here, I'll refresh it. The user interface is grabbing them. Can I use the JSON engine to query them? Of course. So let me go and let's do a key value. This is our key value API. Get record by ID. So this is the key value API. And you just put in the name of the table. So I'm going to put in athlete. And I'm going to say, give me record 1 with an ID of 1. Let's see what it looks like. Who's the first record we inserted with ID of 1? Oh, it's Michael Jordan. There's Michael Jordan. All right, let's get another one with a different ID. In fact, let's get a couple of them. Let's go odd numbers. 1, 3, 5. You can use this quickly to look up records very efficiently. If you get a foreign key to another table, you can use this to go drill down and cut across the tables efficiently at your to join data when you want to, exactly how you want to. So here's one records 1, 3, and 5. So I got the Michael Jordan, and I got Muhammad Ali, and I got Wayne Gretzky. All right, so that's the ID. We have this really fast key value API. We bypass the entire SQL engine. We're going straight to our incredibly fast FairCom database engine, and we're gathering those records and bringing them straight back to you with predictable performance, low latency, and high velocity. So this competes against DynamoDB and all your other key value databases out in the market. So this is a simple key value, but we do way more than key value in this JSON API. So now here's a really cool one. I'm going to get records by an index. So let me go and I'm going to change it to an athlete, and let's just grab the records. So here are the records in index order. Now this is in the ID index, and you'll see it's IDs 1 and then ID 2. So they're in ID order because I said get them out of the index in ID order. The index is really cool because it allows you to query data in sorted order, in the order that's sorted by the index. You don't have to sort the data. Like in the SQL engine, SQL is going to have to sort that data. Sometimes SQL is smart enough to use an index to get sorted data, and sometimes it makes you sort it. It depends on what the optimizer is choosing to do. This bypasses SQL. It gives it to you in sorted order. So this is when you want to get records out of a table in index order. And it's especially useful to use those predefined indexes I talked about, where you put conditions in your index definition, and so you create indexes that are already queried, that are already filtered. So now you're getting filtered records. So if I were to change this index here to go name lived, if I can type it right, remember how I lived past 2000. Okay, I did type it right. So now I'm going to get the records from that index. And this time, if you look closely, that was a reverse index. So now the records are in backwards order. There's 5, 4, 3, and then 6, and then 1. And then here is we don't have Babe Ruth is not in here because he did not live past 2000. So this query very quickly gives you the answers to questions. So that's why this exists, to use those custom indexes. Now let me go to another really cool custom approach to querying data. So I'm going to go query this one. I'm going to query the athlete table. I'm going to use the ranking index, and I'm going to use I'm actually going to use the name past 2000 index, which leaves out Babe Ruth. And I'm going to do a table filter on this thing, and I'm going to say, this is a new feature I haven't told you about yet. You can add, just like the where clause in the SQL statement, you can add where clauses to these specialty queries, but they are super fast in comparison to SQL because in this particular one, I'm getting records by an index, and I'm doing it by a partial key range. So I'm going to get all the records that match the name N. So that would give us things like Michael Jordan and Michael Schumacher. I'm also using the index that's pre-filtered, so it's already taken Babe Ruth out of the picture, and so I can use specialty indexes that are pre-filtered. I can filter the table records as the index is getting them, filter them with any expression I want. This is a very powerful feature that bypasses the SQL engine with its overhead of parsing SQL, doing an optimizer plan, executing the plan, getting the records back. Every SQL engine has all those layers. This bypasses all of that, goes straight to our incredibly fast engine. It gives you the answers. So I'm going to run this one. And so here we go. It came back with, here we go, Muhammad Ali and Michael Jordan. And this time I actually said, give me include fields, just names. So here's only the name field. So I've got the name. So I only see names. So you can do like the select clause does in SQL and pre-filter the data. So you just want names of people, you can get that. So we have a whole bunch of really cool functions like get records by table, which will for tables that are not too large, say they only have 100,000 records in them. In one query, boom, you can get back every record in that table. And it's incredibly fast because it just gets the data and streams it back as fast as possible. Here's one that cursors are really cool. You can now paginate your data automatically. So I got to show you this real fast. So I'm going to get records. Oh, first I'm going to run one of these regular queries. I could do key range queries. I could say, give me records in the athlete table where they lived past 2000, where the name is greater than or equal to P. And then I can return the data as a cursor. So let me get that one. I need to find the cursor one. Well, I could just say, oh, I'm running out of time, so I'm going to go fast. You can return a cursor, and then you can paginate just by calling the cursor. What's really cool about the cursors, you can have as many cursors as you want. The server remembers where you are, and so it's very efficient to come back and get the next 10 records. You just say, get the next, and it efficiently returns the data to you at a high speed. You also can do queries you can actually do this really cool SQL query. You can use SQL to query JSON. Sorry, you can use JSON to query SQL. Let me reverse that. So now I'm getting all the records back from athlete using JSON. So I used a JSON query. JSON data came back, but I used SQL, and I could put where clauses in SQL. Just any SQL statement will work here. And so here I've got the data. So so you could query. We've got all these really we've got these amazing specialty queries that give you high performance, starting at keys in the column. You gotta let us give you a demo because we'll go through this and you can answer questions. You can ask questions, we'll answer them. We'll show you this in more detail because we get all the power of these specialty NoSQL databases and more power than they give you, like way more power than DynamoDB and MongoDB. We give you the full power of SQL. We give you the full power of event streaming, all on the same data at the same time through simple JSON APIs. And there's nothing easier than these APIs. No drivers are needed. You just simply post these JSON to your endpoints. Every language can do it. There's not a language that can't do it. So that's my story today about JSON DB and our messaging API. And last thing, send an email to hello@faircom.com. We're not going to spam you. We're an engineering company. We hate spam. And so what we're going to do is we'll give you a developer's license of FairCom DB. It won't time out. You can use it to develop your dream application in the cloud everywhere. You can't use it in production. Well, for real, for paid applications in production, but you can use it to develop all the applications you want. So contact us. We'll get you a developer license. And this is way better than open source even because we'll give you source code if you buy our version, if you want it. But what's key is you get the real full working version of our product to develop your dream solution just by emailing us.
All right. Well, thank you guys so much for coming. As Mike said, you can email hello@faircom.com to get a developer version of FairCom DB. In addition, if you have questions for our engineers, feel free to throw them out there. Thank you guys, and you all have a great day.